Hello friends, happy Ugadi to all my subscribers and audience. In this video, we are going to discuss how displacement, velocity and acceleration of particle changes with the time during its simple harmonic motion, right? So for that, I am taking uniform circular motion as an example. Why? Because when particle is under uniform circular motion, its projections on both x and y axis oscillates to and fro periodically, in which acceleration is directly proportional to displacement and acceleration is directed always towards mean position, etc. So here projections are under simple harmonic motion. That's why I'm taking that example into account, right? Now see, here one particle is there like this, which is moving along circular path with constant speed. See, this is what x o x dash is the axis. Here it is y o y dash. So here particle is moving in a circle with constant speed, means that is what uniform circular motion, right? So at t equal 0, let y be the position of the particle. At a given instant t, it reaches t equal t, it reaches position p. Now what is its radius vector, otherwise amplitude? This is the radius vector, otherwise amplitude a. This is what a, right? Amplitude. Here radius itself amplitude. Now if I take normals onto both x and y axis like this, see this is what x axis. So x axis, I am taking one normal onto x. So here interception is nothing but projection on x, nothing but displacement of projection, that is x, from main position to this. Similarly, if I take one more normal onto y axis like this, see this interception is nothing but projection on y axis. So that is equivalent to say that displacement of particle along y axis. So otherwise this is what projection on y axis, y, right? Now within the time interval 0 to t, what is the phase angle acquired by the particle here? That is theta or pi equal to omega t. Omega t. Pi equal to omega t. So here simultaneously the particle possesses two displacements. One is displacement along x and another one is displacement along y. Right? So that's how it possesses two displacements in two mutually perpendicular directions. Right? Now I took y o y dash as the reference axis. Then I have to consider displacement on x, that is projection on x. If I take x o x dash is the reference, then I have to consider displacement, otherwise projection on y axis. So accordingly, what is the expression for displacement here? First one, displacement x. I am interested in taking y o y dash as the reference axis, so that's why I am taking x as the displacement. So here it is pi equal to omega t. Therefore sin pi equal to displacement sin pi. From the diagram, sin pi equal to opposite side by hypotenuse. What is opposite side here? X. Here it is x, here also x. So x by hypotenuse a, x by a. X equal to a sin pi. X equal to a sin pi. That is a sin pi means what? Omega t. Otherwise 2 pi by capital T into small t. Right? This is what expression for displacement. Now coming to velocity here. What is the velocity acquired by the particle on reaching this position? Of course, it is under uniform circular motion, means implies that speed is constant. Now what is the velocity v? How will you get velocity here? V equal to, on differentiating x with respect to time, the rate of change of position with respect to time is velocity. That is v equal to what? V equal to dx by dt. So on differentiating this expression, a omega cos omega t, right? On extending, of course, on extending cos omega t means 1 minus sin square omega t. Sin omega t means what here? X by a. So it is equivalent to say that omega into that is a omega and root over 1 minus cos sin square omega t, that is sin square omega t. Already we did this derivation. So sin omega t means here x by a, that is x by a whole square. So a omega root over 1 minus x by a whole square, that is on simplification we will get omega into root over a square minus x square also. So here we have two expressions for velocity. One is a omega cos omega t, another one is omega into root over a square minus x square. Now third one, what is the expression for acceleration? Acceleration a of the particle. So on differentiating velocity with respect to time, we will get acceleration a equal to dv by dt. So on differentiating this expression, it becomes minus a, that is minus omega square into a into sin omega, minus omega square into a sin omega t. Now what is a sin omega t? A sin omega t in the sense a sin omega t is nothing but x, that is equal to say that minus omega square into x also. So a equal dv by dt, otherwise on differentiating v, this expression with respect to time will get minus omega square into a into sin omega, that is minus sin omega square into, that is minus omega square into x also. Right, here acceleration is proportional to minus x. Acceleration is directed opposite to the displacement, also directly proportional to displacement. That's what the condition of simple harmonic motion. Condition of simple harmonic motion. So let us see during uniform circular motion, when particle is under uniform circular motion, how its projections making simple harmonic oscillations. Let us see all the required qualities. What is the required factors here? First one, time period must be constant. See, first one, point number one, otherwise a time period is, what is time period here? T equal to, time period equal to 2 pi by omega, that is 2 pi by omega means what? Angular frequency. Angular frequency, that is omega equal to v by r, speed by r, that is 2 pi r by v. Here see, r is the radius of the circular path, r is constant. Why? Because particle is under circular motion with constant radius. So 2 pi constant, r constant, speed also constant. Why? Because here particle is under circular motion with constant speed. So 2 pi r constant, v constant. So time period also constant. So time period constant in the sense here motion repeats itself at regular intervals. Okay, one condition is fulfilled. Next one, what is the other condition? Motion must be to and fro. Motion must be to and fro. Here, time period of particle is constant, implies time period of oscillation projection also constant. As time period of particle during its revolution is constant, the oscillation of its projections on both x and y axis, that is x projection and y projection, oscillates like that. So here, within one revolution of the particle, here x projection also completes one oscillation about the main position to and fro like this. In the same way, projection of y-axis also completes one oscillation, that is either side of center in that time in which particle completes one revolution. So that's why time period is constant for both x projection and y projection, right? So next one, motion must be to and fro. To and fro. How it is to and fro? See, during first quadrant, during the motion of particle in first quadrant like this. See, particle is moving like this, clockwise for example. So in first quadrant, y projection decreases, x projection increases. In motion in the second quadrant, x projection decreases, y projection increases. In motion in fourth quadrant, motion in the third quadrant, again y projection decreases, x projection increases. During the motion in the second quadrant, x decreases, y increases. See, this is y, this is x, this is y, this is x. See, in revolution, y projection oscillates about fixed point O like this. X projection also oscillates about O, about center like this. So These two are in to and fro motion with fixed time period. So y projection oscillates like that, x projection oscillates like that. That's why motion is to and fro. Of course, here motion of particle is not to and fro, but its projections are in to and fro motion, right? So second condition is fulfilled. Now, what is the third condition? See, what is the third condition? Acceleration of projection. Acceleration of projection must be directly proportional to x, and also directed opposite to the displacement, and also acceleration always directed towards mean position. Now let us see that condition. See here, I am drawing a is proportional to minus x. This is the third condition. I am drawing like this. Same diagram. See here, 4 quadrants. When particle lies in the first quadrant during its clockwise revolution like this. See, this is what here particle is directed to go around the circle because of some resultant force. That's what centripetal force. Centripetal force always directed towards center of the circle. So implies that it's a relevant acceleration. That's what so-called centripetal acceleration also directed towards mean position, towards center. This is what AC acting towards center. When it is divided into two components here, this is what AY, this is what AX, right? AY, AX, AY, AX. This is what AY, AX. Here, see, when particle lies in first quadrant during clockwise revolution, now what is the displacement here? Displacement is along, see the x projection, away from the center, So x. Here Ax, see here Ax towards negative x-axis, but the displacement on x-axis is towards positive x-axis. See, these two directed opposite to each other. Acceleration is directly proportional to negative of displacement. See here, Ax and x directed opposite to each other. Directed opposite to each other. So Ax is proportional to minus x. In the same way, see here, what about y coordinate? Displacement along y-axis, that is y projection upwards here. That is towards positive axis. So this is what y. But here see these two vectors here, displacement along y is along positive axis, but ay is along negative axis. See these two arrows directed opposite to each other. So ay also proportional to minus y. A suffix y is proportional to minus y. A suffix x is proportional to minus x. So in the same way, we can have the similar diagram somewhere here also. Here also. Suppose here particle lies somewhere here. Now assign the direction of centripetal acceleration towards center AC. Now it is divided into two components. One is along x, another one is along y. This is what naturally ax, this is what ay. But here, see the when particle lies in the third quadrant during its clockwise revolution. See ax like this, but displacement is like this. Displacement along x. See these two directed opposite. Similarly, these two. See along y-axis, this is what displacement. When particle lies somewhere here, displacement along y-axis is downwards. Displacement along the x-axis is leftwards. So x and ax directed opposite. Y and ay also directed opposite. So in the same way, we can find the same situation even in fourth and second quadrants also, right? So that's how acceleration is directly proportional to displacement and directed opposite to each other. So these are the conditions. As all these conditions are satisfied, we can say that during uniform circular motion, the projections on x and y axis oscillates simple harmonically, right? Now let us see how displacement, velocity and acceleration varies with the time during the uniform circular motion when particle is under uniform circular motion, right? Now let us see all the graphs. Here 4 situations may arise First situation, when particle is at x equal to 0 at t equal to 0. So initially particle starts from mean position. Then what is the valid condition, valid expression for SHM? X equal to a sin omega t. X equal to a sin omega t. Right? See how displacement, velocity and acceleration varies with time. As per the sine or cosine functions here, we have to consider sine or cosine functions. If you want to express the variation of x, v and k with time, right? Now, situation number 1. When t equal to 0, particle is at x equal to 0 and moves along positive x-axis. That is the first situation, right? Situation number 1. When t equal to 0, when t equal to 0, particle is at x equal to 0. Now, what is the required SHM equation here? X equal to, see here I want to draw graphs between x versus t, v versus t and a versus t, all in the same diagram like this, right? All in the same diagram, right? Right. So this is what time along y-axis, position x. So displacement versus time. Next, displacement versus time over next velocity versus time. Velocity versus time. Velocity versus time. Next, acceleration versus time. Acceleration versus time. Right? Like this. Now, for this situation, t equal to 0, what is the position of particle? Mean position. And see this positive sign here. Of course, particle is at mean position but moving along positive x-axis. Now, what is the valid equation here? X equal to plus a sin omega t. Exactly same one. That is x equal to, what is the valid expression here? X equal to a sin omega means 2 pi by capital T into small. This is the required equation. Now, as x contains sine function here, sine, how sine function varies with the time? See, sine wave like this, sine wave. This is the variation of displacement with the time, right? See, here it is 0, here it is t by 2, here it is capital T, here it is t by 4, here 3t by 4. Now, I want to divide the each crest or each trough into 2 equal parts like this to have other diagrams also. See? Right? So here also I want to divide the crest into 2 equal parts, crest also into 2 equal parts like this. Okay. And next one, here also like this. Right. Now coming to velocity. What is the expression for velocity here? See, a omega cos omega t, cosine function, plus a omega cos omega t. So plus cos omega t means at t equal 0, it starts from positive peak like this, right? Now it becomes 0 and again becomes maximum at the negative side and again becomes 0 and again like this. So this is what variation of velocity with time, right? So what is the expression here? V equal to a omega into, otherwise omega into a cos omega, right? Omega into a cos omega. Omega means 2 pi by capital T also. 2 pi by capital T into small here, right? So by varying time here, at t by 2, otherwise t by 4, 3t by 4, capital T, by changing time we can have all these values. Suppose if I substitute t equal to small t equal to 0, small t equal to 0 means Sin 0 0, x equal to 0. At t equal to 0, x equal to 0. In the same way, at t equal to t by 2, at small t equal to t by 2, t cancel, sin pi. Sin pi means what? 0. Like that. At t equal to 3t by 4 here. That is sin 2 pi by capital into 3t by 4. Then also you can have minus 1 here. Minus. So what is this peak value here? Plus a. Positive amplitude. Here it is minus a. Plus a. Here it is minus. Here what is the maximum velocity during the oscillation of particle here? Simple harmonic. That is plus omega into a. Here it is minus omega into a. Minus omega into. So at main position, as it moves in the positive x direction at main position, what is the max velocity plus omega? If it crosses the main position in negative x direction, then it has minus omega like that, right? So in the same way, as far as acceleration is concerned, what is the expression for acceleration here? A equal to minus omega square into a sin omega. See here, omega square into a, omega square into a is common. Here minus sin omega t. Minus sin omega t. Here it is sin omega t. Sin omega plus sin omega t. Here it is minus sin omega t. Means simply just invert the variation of x with the time. Just invert. So this crest goes into trough. This trough goes into crest like that. So this crest goes into trough like that. This trough goes into crest like that. So that means to say that the phase difference between displacement and acceleration. See, crest goes into trough, trough goes into crest. In the sense, both are differ by a phase angle of pi radian. So between x and acceleration, phase difference is delta pi equal to pi radians. Between displacement and velocity, see here, when displacement is 0, velocity has peak value. When displacement is maximum, here velocity becomes 0. So when displacement is 0, already it has maximum value at its maximum. So what is the phase difference between these two? Pi by 2. So between x and v, phase difference equal to delta pi equal to pi by 2. That is, velocity is pi by ahead of pi by 2 radian over displacement. In the same way, what is the phase difference between these two? Again, that is pi by 2. So between v and a also, delta pi equal to pi by 2, right? Like that. These are the variations. Now coming to other situation, when t equal to 0, particle is at x equal to 0 but entering in negative x direction. That is minus, not plus. Means when our observation starts, particle crossing the main position in the negative x direction. That is the situation. Now here x becomes minus a sin omega. Minus a sin omega. Minus a sin omega. So simply take negative sign here. Negative. Minus. Minus in the sense it becomes, crest becomes trough. Trough becomes crest. This is what plus sin omega t. Plus sin theta. Minus sin theta means it takes like this. This is the form. So crest goes into trough. Trough goes into crest. So like this. This is the variation, right? This is what t by 2. T by 2, right? So this is the variation of displacement with the time. Now what about the velocity? Velocity equal here also. On differentiating, we can have minus a omega cos omega, minus cos theta, minus cos omega t. Minus cos theta means it is plus cos theta. If it is minus cos theta, same curve goes down like this. Just make it reverse, make it invert to have minus cos theta. So graph starts from negative peak value like this. That is like this. Right? This is the variation. This is the variation. This is what minus cos theta. Minus cosine wave, right? As far as acceleration is concerned, what about acceleration? On differentiating this expression, here also we can have minus or minus plus, that is plus omega square into x, plus plus sine omega t. Here it is minus sine omega t, but here it is plus sine omega t. Plus means just make it invert like that. So here crest goes to trough goes to crest like this. Again crest goes to trough. Now what about values here? Peak value of acceleration plus omega square into a. Here it is minus omega square into a. Maximum accelerations you can find at extreme positions. In the positive side, at the positive extreme position, maximum acceleration equal to plus omega square into a. In the negative extreme position, maximum acceleration equal to minus omega square into a, like, right? So here it is t by 2, here it is capital T, like that, in the same way. So 0, t by 4, t by 2, 3t by 4 and capital T, right? So that's about the variation of displacement, velocity and acceleration with time in case of when at t equal 0, x equal 0 with the negative sign, like that. Now third situation number 3, when t equal 0, initially particle is at the positive extreme position, that is plus a. Positive extreme position. What is the expression here? When particle is at the positive extreme position, valid equation for SHM equal to a cos omega plus a cos omega t plus a cos omega t. That is plus a cos omega. That is 2 pi by capital T into small t. Right. So plus cos theta means how it varies? Plus cos theta. Cosine means graph first starts from peak value in the positive side at t equal to 0, like this. Like this. See, this is the variation. Right? Okay. Now coming to velocity and differentiating this one, we can have minus omega into sine 2 pi by t. Sine omega t. Sine 2 pi by t. Minus sine theta. Minus sine theta means not like this. Sine wave. Negative sine wave means like this. Like this. Okay. Negative sine wave. In the same way, what about acceleration here? A equal to on differentiating this one, we can have minus omega square. See here, minus omega square into a cos 2 pi by capital into small. Right? So minus cosine. Negative cosine function means negative cosine, like this. See, this crest grows, this part goes into down. That is like this. Why? Because these two are differ by a phase angle of 180 degrees. Therefore, like this. Graph will be like this. Okay. Now coming to fourth situation. Number 4. When t equal to 0, if x equal to minus a is the position of the particle, that is when our observation starts, particle is at negative extreme position. Now the valid equation for x equal to minus a cos 2 pi by t. Minus cosine wave, that is from negative side. So at t equal to 0, it starts from negative extreme position, like this. Like this is the variation, right? This is the variation, right? Next, velocity. On differentiating x, we can have minus or minus plus omega into sine 2 pi by t. That is plus sine theta. Plus sine theta means like this, not like this. Sine wave, positive sine wave, like this. Positive sine wave. Okay. See, this is what t. Positive sine wave. Okay. Now coming to acceleration. What about acceleration? A equal to dv by dt. On differentiating this one, we can have plus omega square into a cos 2 pi by t. That is positive cosine wave. not like this. This is what minus cos theta, but here it is plus cos theta. Plus cos theta in the sense like this. Exactly opposite to this one. Just make it invert. It is from positive extreme side. It is trough again positive side like this. So this is the variation of respect to displacement, velocity and acceleration in case of circular motion. Okay friends, thank you. We'll meet in the next video.